So for my ECE 2140 final project, I chose to do the rock, paper, scissors on a basis 3 board. The specifications for this project were that switches 0 through 2 were used for player 1, switches 13 through 15 were used for player 2, and that the results of the game were to be displayed on one of the 7-segment displays here on the board. It would display a 1 if player 1 won, display a 2 if player 2 won, a T, which I've changed to an equal sign because it's kind of hard to do a T on these if it was a tie, and an E for any other cases. So for the design flow, I started with the truth table for a decoder, since that would be necessary for the 7-segment display. At first, I have the 3 cases where a tie would happen, then player 1, player 2. I set up the 7-segment display here so that it would display an equal sign for the ties, a 1 for player 1 and a 2 for player 2. When everything's at 0, I set none of the lights to light up, since that's not an error. And then every other case, all the other 54 other possible combinations are an E for an error. Then I took this truth table and I made K-maps for each of the inputs. So this is A and E. They actually have the same displays, so those could be combined in one. B, C, D, and F, and then G is over here. And then from these 6 variable K-maps, I could create the circuit that is right here. This is essentially a very messy decoder with 6 inputs and 7 outputs, but 6 because A and E are the same. Alright, so here we have the Verilog code for this implementation. It's actually much easier to implement this on the basis 3 board than it is with gates. As you can see, the circuit was very complicated, but right here we only have about 10 lines of code because you only have to define each case, and there's only 10 cases, and then just write a default statement for the rest of them, setting it to E. So here on the actual board, you can see it's going to work perfectly here. I'll show the 10 cases and then a few E's just to show that's working. So I'm going to start with the ties. I'll do both rocks, it's an equal sign, both papers, it's an equal sign, and both scissors as an equal sign. Now I'll show the 3 cases where player 1 wins. So if player 1 selects rock and player 2 selects scissors, we have a 1. If player 1 selects paper and player 2 selects rock, we also have a 1. And if player 1 selects scissors and player 2 selects paper, we also have a 1. Vice versa, if player 2 selects rock, player 1 selects scissors, we have a 2. Player 2 selects paper, player 1 selects rock, we have a 2. And if player 2 selects scissors and player 1 selects paper, we have a 2. And also, as you can see, at the 0 state, there's no lights on because no one has selected anything. So if you turn on more than one LED, you're gonna get an error. Seen here, I mean, there's 54 possible combinations, so I'm not gonna go through them all, but I'll show a few. All 3 on, all 3 off, it's an error. Only 1 on, no, the other player has not selected anything, it's gonna be an error. If one player does 1, the other does 2, it's gonna be an error. If all players do all 3, it's gonna be an error. So all 54 combinations work. But so yeah, that is the rock, paper, scissors implemented on a basis 3 board.